Hello everyone. So in this pre-lecture tutorial, we're going to pick up from where we left off in the last tutorial where we learned how to determine molar masses. And now we're actually going to apply those molar masses as conversion factors so that we can actually convert between mole and gram units. And so I'll give you a couple of examples so that you can see how that's done. And as usual, you'll have a chance to practice a little bit more with the follow-up assignment, and we'll continue to reinforce in class. So again, basically in this first example, I've been asked to convert 3 moles of diarsenic trisulfide to grams. And so much like our typical dimensional analysis setup, the best place I guess to start would be to write out your given information. So you have 3 moles of diarsenic trisulfide. And I'm going to set up a multiplication sign and begin to assemble my first conversion factor. So if you recall, if I have a set of units in my given information, then they will appear in the denominator of my first conversion factor, so that those units will cancel each other out. And I want to convert to grams of diarsenic trisulfide. And so if you recall, this set of units, grams per mole, those are units of molar mass. And so that signals to me that I need to calculate out the molar mass of diarsenic trisulfide. And I start to do that by first counting up how many there are of each of the different types of atoms in this particular compound. And so in diarsenic trisulfide, I have 2 arsenic atoms and I have 3 sulfur atoms. And so I'm going to go to my periodic table and I'm going to look up the molar mass of arsenic. And I can see in the periodic table that if I pull that out to 4 significant figures, that molar mass for arsenic is 74.92 grams per mole. So that would be 74.92 grams per mole, and I'm going to multiply that by 2, since there are 2 atoms of arsenic in this compound. Now, in terms of sulfur, I will have to multiply sulfur's molar mass by 3 since there are 3 sulfur atoms. And so I'll consult my periodic table again, and I can see that the molar mass for sulfur is 32.07 grams per mole. Again, if I pull that to 4 significant figures. And so that is 3 times 32.07 grams per mole. And so I'm going to add this up in this box. So 2 times 74.92 plus 3 times 32.07, and that gives me a molar mass of 246.1 grams per mole expressed to 4 significant figures. And so I'm going to go ahead and incorporate that into my dimensional analysis setup for the problem. And so what the setup is telling me is that I'm going to have to take 3 and multiply by 246.1, and if I do that, I get 738 grams of diarsenic trisulfide. Okay, now let's actually work on the reverse type of problem. So instead of going from moles to grams, I'm going to do one where I'm going from grams to moles. So in this case, they're asking me to find the number of moles that corresponds to 11.5 grams of, and this compound's actually known as ethanol. So I will start off by writing out my given information. I have 11.5 grams of ethanol, and I want to convert from grams of ethanol. So again, notice I'm keeping these units diagonal to each other so that they cancel, and I want to convert to moles of ethanol. Okay, and again, notice here I have the units of grams per mole, which is typical of molar mass, but notice that the units are in reciprocal form. So that means that when I find the molar mass of ethanol, it's going to go in the denominator, in this case, as opposed to the numerator. So I'll go and I'll start putting together my molar mass of ethanol. Let me count up the different types of atoms. In ethanol, I have 2 carbons. I have 5 6 hydrogens, right? So H5 and then this other H that's hanging out in the end. So that would be 6 hydrogens, and I have 1 oxygen in ethanol. So I'll go and I will consult my periodic table. So carbon's molar mass is 12.01 grams per mole. So that would be 2 times 12.01 grams per mole for carbon's contribution to the molar mass in ethanol. I'm going to have to multiply hydrogen's molar mass by 6, checking the periodic table. Hydrogen's molar mass is 1.008 to 4 significant figures. So it'd be 6 times 1.008 grams per mole of hydrogen. And then lastly, if I look up oxygen, oxygen's molar mass, if I report it out to 4 significant figures, should be 16.00. So that would be 16.00 grams per mole. But notice I only have 1 oxygen in ethanol, so I don't have to multiply it any further. And so I would add this up to get the molar mass of ethanol. And so if I go ahead and do that math, I get 46.07 grams per mole of ethanol if I ran that to 4 significant figures. And so I'm going to incorporate that in my dimensional analysis setup. And as I said, basically I want to include the mass, the 46.07 grams, in the denominator in this case, per every 1 mole of ethanol. So that would mean I would take 11.5, divide by 46.07, and if I do that, I should get the number of moles of ethanol. If I do that math, I get 0.250 moles of ethanol. Okay, so go ahead and work on the follow-up assignment and try and follow along using these examples sort of as a template for you guys to actually put your work together. If you have any questions, by all means email, and again, we will be discussing this further in class. All right, have a good night.